Imagine a world where an entire year is shorter than a single day on Earth. A planet orbiting so close to its star that it completes a full journey around it in about 18 hours. On its surface, solid rock may melt, forming a vast ocean of magma. And yet, this world may have an atmosphere, perhaps replenished by the molten planet itself. But how could an atmosphere survive so close to a star? And how can we know any of this when we cannot see the planet in detail? This is 55 Cancri A, also known as Janssen. Cancri A lies about 41 light-years from Earth in the direction of the constellation Cancer. On the scale of the Milky Way, that is relatively nearby. But for us, the distance is almost impossible to imagine. The light reaching our telescopes today began its journey more than 4 decades ago. Janssen orbits a sun-like star named Copernicus, also known as 55 Cancri A. 5 confirmed planets are known to orbit this star, and Janssen is the innermost planet in the system. It circles only a little over 2 million kilometers from its star. For comparison, Mercury orbits the Sun at an average distance of about 58 million kilometers. But Janssen is not a small world. It is almost twice as wide as Earth and has roughly 8 times Earth's mass. This places it in a class of planets known as super-Earths. But the name can be misleading. It does not mean a larger or more habitable version of Earth. It simply describes a world larger than our planet, but smaller than Neptune. And before astronomers could understand this extreme world, they first had to discover a planet they could not directly see. Astronomers discovered Janssen in 2004 using the enormous Hobby-Eberly telescope at McDonald Observatory in Texas. The team, led by Barbara MacArthur, could not photograph the planet directly. Instead, they watched for tiny movements in its star. As a planet orbits, its gravity gently pulls the star back and forth. Those movements leave subtle changes in the star's light, allowing astronomers to detect an otherwise invisible world. At first, the measurements suggested that Janssen completed an orbit in almost 3 Earth days. Astronomers believed it was a hot planet, more similar to Neptune than to Earth. But years later, researchers examined the observations again. They discovered that the original result had been misleading. Janssen's true year did not last almost 3 days, but only about 18 hours, and what had once appeared to be a hot Neptune was revealed as an extreme super-Earth. Janssen completes an entire journey around its star in about 18 hours. During a single year on Earth, nearly 500 years pass on this distant world. Because Janssen orbits so close to its star, scientists think it is tidally locked. This means the same side may always face Copernicus, while the opposite side remains in permanent darkness. From the planet's surface, its star would appear around 70 times wider than the Sun appears from Earth. On the day side, the heat is intense enough to melt solid rock. Much of the surface may be covered by a vast ocean of magma, beneath a star that never moves across the sky. The night side is cooler, but it is still far from a safe or habitable world. Between these two extremes lies the terminator, a permanent boundary between light and darkness. But one important question remains. What carries heat away from the blazing day side? Flowing magma may move some of it, but the answer may also lie in an atmosphere above the molten surface. At first, an atmosphere on Janssen seems almost impossible. The planet is exposed to intense heat, radiation, and stellar wind. and any light atmosphere left from its formation was probably stripped away long ago. But Janssen may have created a new atmosphere. Deep within the planet, gases can remain dissolved inside molten rock. As the magma rises and moves, those gases may escape above the surface. A similar process occurs during volcanic eruptions on Earth, but on Janssen, it could happen across an enormous ocean of magma. This would produce what scientists call a secondary atmosphere, one formed after the planet's original atmosphere had disappeared. The star may constantly remove some of these gases, while the magma below continues to release more. Janssen's atmosphere could therefore be part of a continuous cycle between the planet's interior, its molten surface, and the space around it. But until recently, this remained only a possible explanation. To find real evidence, astronomers needed the James Webb Space Telescope. The James Webb Space Telescope cannot take a detailed photograph of Janssen's surface. Instead, it studies the faint infrared glow of the planet. Webb observed Janssen as it moved behind its star, an event known as a secondary eclipse. Before the planet disappears, the telescope receives light from both the star and the planet. While Janssen is hidden, Webb measures only the star. By comparing these two moments, scientists can separate the tiny signal coming from the planet itself. Using the NIR-CAM and MIRI instruments, Webb measured the heat escaping from Janssen's dayside. A completely bare lava world was expected to reach more than 2,000 degrees Celsius, but the measured temperature was closer to 1,500 degrees, still hot enough to melt rock, but cooler than scientists expected. This suggests that something may be carrying heat away from the permanent dayside, and the planet's infrared spectrum offered another clue. The measurements are consistent with a heavier atmosphere, possibly containing carbon dioxide, carbon monoxide, or other volatile gases. Scientists do not yet know its exact composition, its pressure, or how stable it may be. But the evidence suggests that Janssen is not simply a bare ball of molten rock. Above its magma ocean may exist a substantial secondary atmosphere, continually connected to the world below. Janssen may be even stranger than a simple lava world with an atmosphere. When astronomers observed the planet at different times, they found that its infrared brightness could change rapidly. In some observations, the day side appeared much brighter. In others, its signal was far weaker. This suggests that Janssen may be a constantly changing world. Powerful volcanic activity could release fresh gases and dust above the surface. Another possibility is the formation of temporary silicate clouds, formed as vaporized rock cools and condenses. Scientists still do not know the true cause, but the variations suggest an active connection between the magma ocean and the atmosphere above it. Janssen is also widely known by another name, the Diamond Planet. Earlier models suggested that its interior might contain large amounts of carbon, possibly in the form of graphite or diamond. But this idea was based on uncertain estimates of the system's chemical composition. Later measurements made the picture far less certain. We have never seen diamonds on Janssen, and there is no direct evidence that the planet is filled with them. The name is fascinating, but for now, the Diamond Planet remains an unproven possibility. Janssen is far too hot to support life as we know it, but that does not make it unimportant. It may offer a rare glimpse into the evolution of rocky planets. Long ago, worlds such as Earth, Venus, and Mars may also have passed through periods of extreme heat, with molten surfaces and newly forming atmospheres. By studying Janssen, scientists can explore how a planet's interior, its surface, and its atmosphere interact with one another. How quickly can a nearby star strip an atmosphere away? Can gases released from magma build a new atmosphere? And how long can that atmosphere survive? The answers may help us understand why rocky worlds, even those born from similar materials, can follow very different paths. 41 light-years away, Janssen continues to race around its star. Its year ends in only 18 hours. Molten rock may cover its surface, while an atmosphere, perhaps fed from below, moves above it. We cannot see this world in detail, but each time it disappears behind its star, a tiny change in light reveals another part of its story. And somewhere within that faint signal, we may be seeing how a rocky planet rebuilds its sky.